Okay, Algebra 2 class. Yesterday in class, we reviewed a little bit about or talked through the manipulation of everything. Now, we did also the Pascal's triangle. So today we're going to do option 3. Option 3 is by using the binomial theorem. So even though I'm not there with you today, I'm there with you today. I'm for you. So here, this is a little video. I'm going to share it with you. You're going to have a link in your email with it. I'm also printing these 2 pages of notes. I should go like this. These 2 pages of notes that I'm going to have for you. I'll print those as a PDF and also put that in the email to you. So you'll have this video and the PDF of notes for these 2 slides. So don't worry about getting everything written down. You're not going to have enough time to do that. You can watch the video over and over as you need to. Or just look at the notes. Okay, let's get going. So option 3 is the binomial theorem technique. Okay, what's that binomial theorem? We've talked about it before. Binomial theorem. It's on page 614, I believe, in the middle of the page, if you need that, Cassie. Okay, it's parenthesis, a plus b, close parenthesis, to the nth power. So it's that same thing we've been talking about, equals, we got the big sigma notation right here. Let's see, I need my good pen, my magic pen, there we go. So we got the big sigma notation, whoops, right there. That means sum up. We're just going to add a bunch of things. We're going to let k start at 0, go all the way up to n. Okay, n is the exponent on the binomial expansion. And then we have the formula n factorial over n minus k factorial times k factorial times the terms a to the n minus k power and b to the k power. So that's the theorem. Now the problem that we had yesterday was 2a minus b over 3 to the 6th power. So that means if I'm going to put this into my binomial expansion, which I should do, k is going to equal 0, sigma notation, 6 on top, 6 factorial, because that's the n, 6 factorial, or 6 minus k factorial times the k factorial, times the quantity, got the parentheses here, notice the parentheses, the 2a, because the 2a is our first term in our binomial expansion. And then in the next one, I have a negative b over 3 in parentheses, okay, because the negative 3 or the minus b over 3 is the second part. So those are the terms we have. Now, we know the n is 6 because that is the number on the exponent. So what do we do with this? What we do with this is we got to find each of those terms. Remember when we did the sigma notation, we had to find all the terms in the sequence that we're going to add. So the first thing I got to do is I got to put k equals 0 in. So that means I have 6 factorial over 6 minus 0 factorial, 0 factorial, times the quantity, parentheses, 2a, that's in parentheses, 6 minus 0, and our negative b to the 0 power. Here's the neat thing about this. 0 factorial is 1. So that leaves me with a 6 factorial over a 6 factorial. If the numerator and denominator are the same, that's 1. So this whole fraction out here in the beginning, this whole fraction here, wow, that blew up there. That whole fraction is just 1. So it's gone. And anything raised to the 0 power is 1. So this negative b to the 3rd or over 3 is gone. So that just leaves us with 1 times 2a to the 6th power, which means I got 2 to the 6th power, a to the 6th power, which means I have 64 a to the 6th. Now we got that when the k was 0. So that's our first term. Well, then I got to do it when k is 1. So now I'm just going to replace all the k's in that formula with a 1. So I have 6 factorial over 6 minus 1 factorial times 1 factorial. The 2a in parentheses is going to get a 6 minus 1. And then I get a negative b over 3 to the 1 power. I don't know why it looks like it's a 4 or something there. So now we got to clean it up. 6 factorial, 6 minus 1 is 5. So I've got a 6 factorial over 5 factorial, 1 factorial, and then a 2a to the 5th, and then negative b over 3. I dropped the 1. You could leave the 1 there if you want to. So now, if we clean that up a little bit more, oops, too far. That means I've got a 6 times 2 to the 5th times an a squared times a negative b over 3 to the first power. Well, 2a to the 5th is 2 to the 5th is 32 times 6 is 192. And then if I bring that up, that's an a to the 5th, an a to the 5th. I don't know what's going on there. So I have a negative 192 a to the 5th b over 3. It's negative because our minus b over 3 had a first power. Odd number of exponents on the negative number gives you a negative value. So now the next time I run through it, I like k equals 2. So I put a 2 in for the k in our formula. So I got 6 factorial over 6 minus 2 factorial times 2 factorial. I've got the 2a to the 6 minus 2 power. I got a negative b over 3 to the 2 power. Clean it up a little bit. 6 minus 2 is 4. So that means I got a 6 factorial over a 4 factorial times 2 factorial. 2a is raised to the 4th power, negative b over 3 to the 2nd power. So now if we clean it up a little bit more, I've got 15, because that's what the factorials all come out to be. I got a 2 to the 4th, a to the 4th. I've got a b to the negative, or negative b to the 2nd, and a 3 to the 2nd. So I've got to take 2 to the 4th power, multiply that by the 15, and I've got the negative b to the 2nd power. That means it's a positive because 2 exponents there. And if I clean that up, I've got the 240, which is what 15 times 2 to the 4th is, and the 3 squared is a 9. So when my k was a 2, I got 240 a to the 4th, b to the 2nd over 9. Well, now I let k equals 3. I do the whole thing again. I plug it in there into the formula. Whoops, it kind of dropped along the way there, didn't it? Plug it into the formula. So I got the 6 over the 6 minus 3 factorial, 3 factorial. 2a to the 6 minus 3, negative b over 3 to the 3rd power. Clean that up. My factorial becomes 6 factorial over 3 factorial, 3 factorial. 2a to the 3rd power, negative b over 3 to the 3rd power. The factorial simple out to be a simple 20. I got a 2 to the 3rd, a to the 3rd, negative b to the 3rd, all over 3 to the 3rd. Since the negative b is to the 3rd power, that means this whole thing's going to be negative. So I take 2 to the 3rd times 20, and I take 3 to the 3rd, find out those values. That gives me 160, but it's negative because the b was a negative value. A to the 3rd, b to the 3rd, all over 27. That's when k is 3. Well, now I do the same thing again. This time when k is 4. I run it all the way through the system again. So I put the 4 in for the k. So I got 6 factorial over 6 minus 4 factorial times 4 factorial. I got my 2a in parentheses. I got 6 minus 4. I've got a negative b in parentheses, negative b over 3 in parentheses to the 4th power. So I've got 6 factorial over 2 factorial times 4 factorial. The 2a is now to the 2nd power. The negative b over 3 is to the 4th power. So now when I clean up the factorial part, I get a 15. I've got a 2 squared. I've got an a squared. I've got a negative 4. Sorry, I got a negative b to the 4th power, and I've got a 3 to the 4th power. 2 squared is 4 times 15 gives me a 60. The negative b has an even exponent here, so that means it's going to be a positive. And 3 to the 4th power is 81. So we have 60 a squared b to the 4th over 81. Now, are we done? No, because the formula said we had to go all the way up to when k was 6. So I've got to do k equals 5. I put the 5 into the formula for the k. I run it through, yada, 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 yada. Clean it up a little bit. After I do all the cleanup, I get a negative 12 a b to the 5th over 243. We're not done because we got to get k to equal 6. So I put the 6 in for the k. I run it through the formula. Clean it up. I'm left with b to the 6 over 72. Because like the very first one, 6 minus 6 factorial is 0 factorial, which is 1. Which leaves me a 6 factorial over 6 factorial. These cancel. The 2a gets a 0 power, which means it cancels. I'm only left with the negative b over 3 to the 6th power. So that's the only thing I have left there. Now, we ran the theorem. We've got all these terms. What do we do with them? The sigma. Sigma says add them all up. So all I got to do is take and add the first term, which was 6a to the 4th, or 64a to the 6th, and the negative 92a to the 5th b over 3. Add to that the 248 to the fourth b squared over 9. Subtract from that the 160a cubed over b cubed. Sorry, subtract from that the 160a cubed b cubed over 2. Add to that the 60a squared b to the fourth over the 81. Subtract from that the 12ab to the fifth over 243, our k is 5 value. And then bring in the last one, b to the sixth over 72. That is our value. That's the same one if we go back and we look at the other two that we had. It's just another way to do it. Using this theorem, you just find each individual term. As you go about it, you've got to the answer. Okay, that's the third option for expansion. The other thing in the assignment is they want you to be able to find the x term of a binomial expansion. So, example here would be if I gave you x minus 1/2 in parentheses to the 10th power, and I wanted you to find the sixth term. So in that whole sequence, when it's all spread out and it's laid out there, which one's in that sixth spot? Because with the 10th power, it means there's 11 terms. So we're looking for one kind of in the middle. So what are our options? Option 1, we can do algebraic manipulation. We can multiply x minus 1/2 to the 10th power, get it all the way to the very end, and then we just find that middle term, that sixth term. Option 1. Option 2 is we can use Pascal's triangle, and we can expand the triangle all the way down to that row where we have that we need for this one, which would be all the way down where that second number is a 10, and then we could use our pattern and figure out what that would be for the sixth term and just write it down. Or option 3, we can use the binomial theorem. This is the one I'm going with. We're going to use the binomial theorem. I'll show you how that works. Okay, so the first thing I do, if I'm going to do this through the binomial theorem, I know the formula, and it tells me that the a has to be the x. So my formula, a plus b to the whatever power, a is the x, my b is the -1/2, and my n is 10. So now I'm going to plug that into the formula. So I'm going to get k equals 0, sigma notation with the 10 on top. Since my n is 10, 10 factorial over 10 minus k factorial times k factorial. X is going to equal 10 to the x is going to equal 10 minus k power, and the -1/2 is going to get the k power. Now, when I'm trying to find the sixth term, all I got to do is figure out which k value do I have to use, and I run it through there. If you notice back on the last one, k started with 0. So when k was 0, I had my first term. When k was 1, I had my second term. So if I want to have my sixth term, I'm going to let k equal 5. So the quick rule here is whatever term they want you to find, k is going to be one less than that. So I'm just going to rework this problem only when k is 5. So I'm going to put a 5 in for the k. So I got 10 factorial over 10 minus 5 factorial times the 5 factorial times x to the 10 minus 5 power with parentheses in, -1/2, and that's going to get a 5th power. So now when I do that, I get 10 factorial over 5 factorial times 5 factorial, x to the 5th, and a -1/2 to the 5th power. All I got to do is clean that up, and I have my answer. So I got a 252 x to the 5th, a -1 to the 5th power, and a 2 to the 5th power. Well, 2 to the 5th power is 32. -1 to the 5th power is a -1. So that means I got a -254 over 32. Now here's the thing. 252 is an even number. 32 is an even number. I can divide those both by 2 to reduce that fractions. The numbers I get are both even numbers. So I'm going to go ahead and divide it by 4. So I'm going to divide the 32 by 4 and the 252 by 4. And it's going to give me a -63 over 8. And then I have the x to the 5th. So for my x minus 1/2 to the 10th power, my answer is a -63 x to the 5th over 8. So that's just using the binomial theorem, plugging it into the formula, and realizing that k is going to be one less than the term I'm looking for. So if I'm looking for the 12th term, I'm going to have k equal 11. If I'm looking for the 3rd term, k is going to equal 2. That's the way it works. Now, we finally got through all the instructional material you need to complete the assignment. So your assignment, that is due Monday, is assignment number 13, page 615, 14 to 42 even. You now have all the information you need to do it. I know you can do it.